Okay, the next bit of functions is composite functions, which just means when we apply two functions, one after another, we get what we call a composite function. So if we do f first and then g, we can write it in one of these ways. We can write it as gf of x. So the first one's on the inside, like closest to x, so f first and then g. Or we can write it the circle notation, so f of x and then g of f. Or we can write it just as a function inside a function, so g of f of x. So the important thing is that it's f first. If I do a function of itself, so if I do f of x, I can write that as f2x. That just means f twice x. It doesn't mean f of x squared, it means f of x subbed into f of x. So we apply the functions in the order that they're touching. So one close to x first, and you work outwards. So f first, then g. So fg of 1, well, I would do 1 into g first. So I put 1 into g. I get 1 minus 3 is minus 2. And I put that inside f. So minus 2 into f gives me 4. If I do it the other way around, so g of f 1, I put 1 into f first. That gives me 1, and then I put that into g. So 1 take away 3 is minus 2. fg of 2, so do g first, so put 2 inside g. So 2 take away 3 is minus 1. Then put that in f. And f of minus 1, well, that's 1. gf of 2, so 2 into f first, so 2 squared is 4. Then put that in g. 4 take away 3 is 1. Alright, so look, these two actually give us the same answer that time. fg of x, okay, well, I do g of x first, so x minus 3, then I put that inside f, so that's just x minus 3 squared. If I expand it, I'll just leave it like that. If I do gf of x, so I do f of x first, so I get x squared, then I do g, then I put that into there, so that's x squared minus 3, it's just x squared minus 3. You can see the difference, they're not equal. f of 1, so f of 1, so I do 1 minus 3 minus 2, and then I do f of minus 2, oh, sorry, that's g, isn't it? 1 into f gives me 1, I do f of 1, which gives me 1 again. g of 1, so g of 1 gives me minus 2, and then g of minus 2 gives me minus 5. f2x, that means f twice, so put x into f1, so I get x squared, then put it back into f again, so I get x squared squared, which is x4. g2x, so that means put g of x into g, so I get x minus 3 minus 3, which is x minus 6. Okay, let's see if you can try this one yourself. So I'll pause it and write the answers, then you can just check. Okay, so there's your answers. So you should have been fine with the first two rows, and then probably fine with the next row. Just remember here, 2 over x cubed, cube 2 and cube x. Should have been fine with this row. And then the last one here, remember a fraction divided by a fraction. Well, invert the second one, you flip the second one in times. Or you can think of it as like this, 2 divided by 2 over x, times the top by x, times the bottom by x. So you get 2x over 2, then the 2's cancel, so you just get the x. And this one, you can leave it unexpanded, or you can expand it, I don't mind. Okay. The next thing, now we know how to do composite functions, we can talk about inverse functions, which you've seen at GCSE already. So inverse just means that if I have to make fg of x, then when I work that out, if I just get x, then that means f and g are inverses that undo each other. Yeah, I get back to just x. So the key thing here is only one-to-one functions have inverses. So inverse functions can be one-to-one or many-to-one, but only one-to-one have inverses. And if you think about that picture, one-to-one means everything's paired up. So that just means that if I go this way, I can also go back. So they've got inverses. Whereas many-to-one had something like this. So I can go forward, but if I try to go backward, if I was this dot here, I wouldn't know which one to go to. So it wouldn't have an inverse. So we write the inverse as f minus 1. So you've probably seen on your calculator with sin minus 1, cos minus 1, tan minus 1. And it doesn't matter which order we do inverses. So remember, the order does matter for f and g. So f and g is different to g and f. Whereas with inverses, they undo each other no matter what order they're in. So f, then f inverse cancel, f inverse and f cancel. I always just get back to x. So one of the following is the inverse of this f here, so x plus 2 over 4. Use composite functions to find out which one, g of x or h of x. So if I sub in g of x into f, so f g of x should give us, well, 4 lots of x minus 2 plus 2 over 4. If I expand that out, I get 4x minus 8 plus 2 is minus 6 over 4, and that doesn't equal x. So f and g are inverses. But if I try h, f of h of x, so I put h into f, I get 4x minus 2 plus 2 over 4, or the minus 2 and the plus 2 cancel. 4x divided by 4 gives me just x. So this one here is the inverse. So here's the list of common functions in the inverses. So x add k, well, the inverse of that is take away k, times by k, the inverse is divide by k, reciprocal, the inverse is reciprocal, and we saw that here, look, with 2 over x. When I do it twice, I get back to x. So that means it's its inverse as well, just like 1 over x. X squared is square root, or x to the half. X cubed is cube root of x, or x to the third. X to the n is the nth root of x, or x to the 1 over n. And if you look here, the powers are just being inverted. So 2 goes to a half, 3 goes to a third, n goes to 1 over n. So if the power was a fraction, so a over b, the inverse would be power b over a. Sine x, the inverse would be sine minus 1x, or we can write that available as arc sine x. Okay, so use the table to write down these inverses. So x plus 7, inverse is x minus 7. X minus 7, the inverse is x plus 7. 3x, inverse is x over 3. Or you could write that as the third x. The third x, the inverse is 3x. x5, the inverse is fifth root of x, or I can write that as x to the fifth. X to the 2/5, the inverse is x to the 5 over 2. Root x, the inverse is squared. Cos x is cos minus 1x, or I can write that as arc cos x. And tan minus 1x, for the inverse is just tan x. So yeah, the inverse can go backwards as well. So the inverse of x minus k is x plus k. The inverse of sine minus 1 is sine. Okay, we can do some algebra functions as well, as long as we do the same thing to both sides. So we're going to have a go at doing some rearranging. So f, g, h are 3 functions, and I'm making this up, f, g of x equals y. So that's the equation we're going to start with, that's the formula. We're going to rearrange to find expressions for these 4 things. So to get g of x, well, to get g of x, I need to get rid of that f. So I can do the inverse of f to both sides. Remember, I need to do the same thing to both sides. Then these two cancel out. So I'm left with g of x equals f inverse of y. To get x by itself, well, I first of all need to cancel out the f. So I'll do f inverse on both sides. Then I need to cancel out the g, so I'll do g inverse on both sides. So I'm left with x equals g inverse f inverse y. If I want to get f of x, well, I'm going to use this x here. So I've got x equals g inverse f inverse y. So to get f of that, I just put an f at the front, do f at the front of both sides. So it's f g inverse f inverse y. And to get h of x, again, I just start with x equals g inverse f inverse of y, and then just do h on both sides. So h of x equals h g inverse f inverse y. So what does the second one tell you about the inverse of fg? So fg, if I want to get rid of that, to get just x, then the inverse is g inverse f inverse. So it's the other way around, look, which again will be interesting when we get onto stuff like transformations and rearranging equations. And the third one, this one here, why can't I just do g inverse to get rid of that g there? Well, it's because there's an f there. If I had something like this, g inverse fg, that g inverse won't cancel because they need to be touching to cancel. So that doesn't equal f. Okay, so here's some for you to try. So again, actually I'll talk through these two, and you might want to have a go at these two yourself. So to get x, I need to get rid of f, so f inverse on both sides. So it becomes f inverse g y. To get y, I need to do g inverse on both sides. So g inverse f of x. To get g of x, well, I'm going to do g of x. So g f inverse g y. To get f of y, I need to do f of y. So f g inverse f of x. This one here, to get x, I need to get rid of f, so I do f inverse on both sides. So I get f inverse g inverse y. To get y, I need to get rid of g inverse, so I do g of both sides. So I get g f x. G of y, I just do g of y, so I get g f of x. I can write that as g2 fx if you really want to. Get f inverse of x, well, I need to do f inverse of that thing there. So f minus 1, f minus 1, g minus 1, y. Yeah, so can you have a go at these two? And actually, I'll not pause it just so you can see me doing it. So g inverse y, you get rid of g, so g f inverse y, f of x, I do f of that, so f g inverse y, g f inverse of x. Well, there's x, so I'm going to do f inverse first, so f inverse fg minus 1 of y. Then I'm going to do g, and look what happens. The f inverse and the f are touching, so they cancel. So I'm left with g inverse of y, and they're touching, so they cancel. So I just get left with y. And this one, to get y, well, I first need to get rid of g, so do g of x. Then I need to get rid of the f, so fg of x. Yeah, actually, I'll show you that one a bit more detail. So do g on both sides, gx, g and the g inverse cancel. So I just get f minus 1 for y. Then I do f both sides to get that f inverse to cancel, so just get y. F of x, so I just do f of that, so f g minus 1, f minus 1, y. They're not touching, so they won't cancel. Gf of x, so I do g of f, so I do gf, g inverse, f inverse of y. Fg of x, well, I go back to x, and I do g first, because that's the closest to x. So I do g minus 1, f minus 1, y, and then they cancel up. Then I do f of that, so I do f minus 1, y, so they cancel, so I just get back with y. Yes, they're a bit fiddly, but if you can get your head around that, that's going to really help with your algebra skills. Okay, the next thing is expressions, and we're going to manipulate expressions. So the key thing here is expressions are different to equations. Equations have an equal sign, expressions don't. So can't randomly times an expression by 2, for example. If we do need to write an expression in a certain way, then we have to do the inverse. So for example, say I wanted to put this here, and I want to factorize out a 3. Well, I would need a 3 in front of the y, so in order to factorize it. So what I would do is I would times y by 3, but I've changed y, so in order to keep it the same, I would also have to divide by 3, do the inverse. So the 3 would cancel out, look, get back to y. Now I could factorize out the 3, get x plus y over 3. Yes, that's a nice trick that we might have to use from time to time. So x is the same as what I can add 2, then take away 2. If I want to times by 3, I have to divide by 3. And if I want to divide by 4, I have to times by 4. X add 1, well, if I add 2, I need to take away 2, so that's where the x plus 3 comes from. If I want to times that by 3, I need to divide by 3. And if I want to divide by 4, I need to times it by 4. So you're going to write these things in these forms, so you need to work out what goes in the square. So if I want to add 1, I need to take away 1. If I want to take away 2, I need to add 2. If I want to times by 2, I need to divide by 2. If I want to change the sign, I need to change the sign back. If I want to divide by 3, I need to times by 3. If I want to times by x, I need to divide by x. Then I could simplify that. Look, x over x is 1, so I could write that as x plus 1. If I want to divide by x, I need times by x, which again, I could simplify to x squared over x. If I want to square, I need square root. If I want to square root, I need square. If I want to do 1 over, remember the inverse of 1 over, it's 1 over. If I want to do e, the inverse of e is ln. If I want to do ln, I need to do the inverse, which is e. If I want to do 3 to the power, the inverse of that is log 3. If I want to do log 2, the inverse of that is 2 to the power. And if I want to do f, I need to do the inverse, which is f minus 1 of x. And I can do the same with x plus 5 and 5x. So if I want to plus 1 at the end, well, if I want to plus 1, then I would need to have in the brackets x add 4. Because to get plus 1, I need a minus 4, so I add 4. If I want a minus 2, well, to get from 5 to minus 2, I need a minus 7, so brackets, I need a plus 7. If I want a 2 on the outside, I need to divide by 2. If I want a minus on the outside, I need to change the signs. If I want to divide by 3, I need to times by 3. If I want to take out an x, I need to divide by x. So x divided by x is 1, and 5 divided by x is x over 5. If I want to divide by x, I need to times by x. If I want to square, I need to square root. If I want to square root, I need to square. If I want to do 1 over, I need to do 1 over. If I want to do e, I need to do ln. If I want to do ln, I need to do e. If I want to do 3, I need to do log 3. If I want to do log 2, I need to do 2 to the power. And if I want to do f, I need to do f inverse. So can you try the same for the 5x column? So I'll pause it and just write the answers in. Okay, so check that column, see if you've got them all right. There's a few things I want to point out. So this first one here, so on the square root one, you could have just left it underneath the square root, 5x in brackets squared, and just expand as 25x squared. And just be very careful when you use your brackets. Okay, the next task. So it's 3 rows, and you should be able to see that these are a bit in bold. So any expressions equivalent to this first one. So 2 times AB over 5, is that the same as 2AB over 10? 2 over 5AB, A lots of 2B over 5, 2A, 2B over 5, 1 over 5, 2AB. So which ones do you think, if any, are equivalent? First one's not. This one is. This one is. This one's not. This one is. I remember 2 times AB over 5, I can split that up into 4 components. That means 2 times 1 over 5 times A times B. So any combination of these 4 things will work. So that's where that one works. Look, I've got an A, 1 over 5, 2 in the B. This one doesn't work, so I've got 2 2's. This one works, so I've got fifth, 2 A and the B. And same with that one, 2 and fifth, A and the B. Now, this one, 2 times A plus B over 5. Which ones do you think are equivalent? So, first one is. Second one is. This one's not. This one is. And this one's not. Yeah, if you really don't like multiplication, think of it as 2 over 1. So the bottom should stay as a 5. You should never get a 10 on the bottom. And the top is 2 times A plus B. And it's a visible brackets in the fraction. And 2 times A plus B is 2A plus 2B. Or you can leave it factorized like that, 2A plus B. And last one, 2 times 3A plus B over 5. It's equivalent to any of those. The first one, I can do 2 times 3, leave it as a 6, so that works. This one here, I can switch the 2 and the 3 since it's times, so that works. This one here, I can times the bracket by the 2 to get 2A plus 2B, so that one works. This one here, I can times the bracket by 3 to get 3A plus 3B, leave the 2 on the outside, so that works. And this one here, I can do 2 times 3 is 6, and then expand the bracket by the 5th to get A over 5, B over 5, so that one works. So all of them work for that one. Okay, so after expressions, it makes sense to look at some equations. So with the equations, and this is the most important thing in the whole video, so this is where we lose lots of marks in exams by not thinking when we do something. Because you're so used to solving equations like this, just by thinking in your head, well, I need a minus 5, and then divide by 2. And when you're done working that out, when you don't really think about it, you can do that in autopilot, that's where you lose marks and make mistakes. So I want to get you into the idea of we can do the same thing, we can do anything as long as we do the same thing with both sides. So I'm just telling you what I want you to do. First of all, add 1 to both sides. So 2x add 5, I'm going to add 1 to that side, and then I'm going to add 1 to that side. So I get 2x plus 6 equals 10. Multiply both sides by 3. So multiply this side by 3, multiply this side by 3. And again, I want you to use brackets. I can expand it. Look, 6x plus 15 is 27. Square both sides. So 2x plus 5 squared is 9 squared, which gives me 4x squared plus expand that out will give us 20x plus 25 is 81. Square root both sides. So root 2x plus 5 is root 9. So that gives me root 2x plus 5 equals 3. But there's nothing I can do with the left hand side. Subtract 5 from both sides. So 2x plus 5 take away 5 is 9 take away 5. So that gives me 2x equals 4. Divide both sides by 2. So 2x plus 5 over 2 equals 9 over 2, which gives me x plus 2.5 is 4.5. Now we need to solve it by first of all subtracting 5. So you would get 2x equals 4, so x equals 2. Then solve it by first dividing by 2. So you would get, using that one, x plus 2.5 equals 4.5. Take away 2.5 both sides, gives you x equals 2. So you get the same answer. Okay, next one, see if you can have a go at this. Add 1 to both sides. So x plus 1 squared plus 6 equals 10. Multiply both sides by 3. So 3 lots of x plus 1 squared plus 15 is 27. Square both sides. So x plus 1 squared plus 5 squared is 9 squared. So squaring that would give us something nice looking like x plus 1 to the power 4 plus 10 x plus 1 squared plus 25 is 81. Yeah, I can't just square them individually, I have to expand the bracket. Square root both sides. So root x plus 1 squared plus 5. Now look, the square root goes over all of it, equals root 9. Well, this side can be simplified to 3. This side, look, I can't separate the square root, so it just stays like that. X plus 1 squared plus 5. Even though that is a square, I can't square it because it's a plus in the middle. Subtract 5 from both sides. So I get x plus 1 squared equals 4. Solve it by first expanding. Well, expanding that, x squared plus 2x plus 1 plus 5 is 6 equals 9. So x squared plus 2x equals minus 3. Take the minus 3 to the side and solve it. I need to give more space for this, I think. So x squared plus 2x plus 3 is 0. So solving it would give us x, no, why is it not factorizing? Because I made a mistake there. That should be minus 3 equals 0. That should be minus 3. So I get x minus 3, x plus 1. So I get x is 3. This is minus 1. Solve it first by subtracting 5 and no expanding. So take away 5 from both sides. That was that there. So I get x plus 1 squared equals 4. I can square root both sides, look, to get x plus 1 equals 2, or x plus 1 equals minus 2. Take away 1 from both sides, x equals 1, and x equals minus 3. Oh, I've got that the wrong way around, haven't I? This one, I add 1 to both sides. So if I add 1 to that side, I get minus 1 and 4 on that side. Multiply both by 3. So 3 root x plus 1, take away 6. So no, I'm not going to do that. I'm going to just write it in the bracket. Three lots of root x plus 1, take away 2 equals 3 lots of 3. Expand the brackets of 3 root x plus 1, that's just a term, just 3 lots of the term, take away 6 equals 9. Square both sides, so root x plus 1 minus 2 squared equals 3 squared. So if I square that out, I get this squared, so x plus 1, then minus 2 lots of those, 4 root x plus 1 plus 4 equals 9. So that doesn't really help, makes it look nastier. Add 2 to both sides, so root x plus 1 take away 2, add 2 is 3 add 2, so root x plus 1 equals 5. Then solve it. Well, may as well carry on from there, look. So root x plus 1 equals 5. Square both sides, you get x plus 1 equals 25. Take away 1 from both sides, so you see x is 24. This one, add 2 to both sides, so ln x minus ln 4 plus 2 equals 5 at 2, which is 7. Multiply both sides by 3, so 3 lots of ln x, take away ln 4 equals 3 lots of 5, which means 3 ln x, take away 3 ln 4 equals 15. Divide both sides by 4, so ln x, take away ln 4 over 4 equals 5 over 4, which I can write as ln x over 4, take away ln 4 over 4 equals 5 over 4, just read out. Raise both sides as power of e, so e to the power ln x take away ln 4 equals e to the 5. And what I can do here, look, is if there's a take away the power, that means divide, doesn't it? So that means e to the ln x divided by e to the ln 4 equals e to the 5. And then here, look, e and ln cancel out, so I get x over 4 equals e to the 5. Add ln 4 to both sides, so ln x minus ln 4 plus ln 4 equals 5 plus ln 4, so ln x equals 5 plus ln 4. Solve it by first combining logarithms, so if I take away a divide, so ln x over 4 equals 5, then raise both sides as the power of e. So here the e and ln cancel out, so I get x over 4 equals e to the power 5, times both sides by 4, so I get x equals 4e to the power 5. Solve it by first adding ln 4, so it was this one here, so we've got ln x equals 5 plus ln 4. So raise both sides to the power of e, so e and ln cancel out, so we get x equals, and there's a plus in the power there, so I can split up the times, so it's e to the power 5 times e to the power ln 4, and e ln 4 cancels to give you 4. So it's e to 5 times 4, which is 4e5. So same as before. And solve it by first rewriting as 5 as ln something. So ln x take away ln 4 equals ln e5. Yeah, remember if I want to write from ln, I need to do the inverse, which is e. Then here, combine. Or actually, I can use any method. I can do e to the power of both sides, or combine first. So ln x over 4 equals ln e to 5. Raise both sides as the power of e. E ln cancel out, so I get x over 4 equals e to 5 times both sides by 4 gives me that. So you can see all methods give me the same answer. It's just whichever one you prefer. Okay, 3 more, then we'll have my next break. Add 2 to both sides. 2 over x add 1 plus 5 equals 7. Multiply both sides by x add 1. So x add 1 times 2 over x plus 1 plus 3 equals 5 lots of x plus 1. And when I expand that bracket, look, I get 2 plus 3 lots of x plus 1 equals 5 lots of x plus 1. Divide both sides by 2. So 2 over x plus 1 plus 3 divided by 2 equals 5 over 2. Now I can divide both these by 2 individually. So 2 over x plus 2 divided by 2 just gives me 1 over x plus 1 plus 3 over 2 equals 5 over 2. Let's solve it first by multiplying by x plus 1. So here we've got x2 plus 3 lots of x plus 1 equals 5 lots of x plus 1. Now you can expand it and solve it, or I could take away 3 lots of x plus 1 from both sides to get 2 equals 2 lots of x plus 1. I could divide both sides by 2 to get 1 equals x plus 1, and take away 1 from both sides to get x equals 0. solve by first subtracting 3 and using reciprocals. So subtract 3 from both sides gives me 2 over x plus 1 equals 2. Do reciprocal both sides gives me x plus 1 over 2 equals a half. Then I can times both sides by 2, which cancels them out. So x plus 1 equals 1. Take away 1 from both sides gives me x equals 0. Same answer. This one here, multiply both sides by 5. Well, I'm going to do it in the whiteboard. So I multiply this side by 5. I can leave it like that. But if I multiply this side by 5, what happens is this 5 and that 5 can cancel out. So we're left with 3 lots of 2x add 8. Okay, divide both sides by 3. Well, the left-hand side can just be written as y minus 2 over 3. Whereas this side, divide by 3 is the same as times them by a third, isn't it? So it's that. And then look, that third and that 3 cancel. So I just get 1 over 5, 2x add 8. Divide both sides by 2. So this side, the left-hand side, I can write as y minus 2 over 2, which gives me y over 2 minus 1. 2 over 2 is 1. And if I divide this side by 2, again, that's the same as times by half. And remember, I can expand the bracket by the half, which gives me 3 over 5 x plus 4. So it's essentially just dividing that bracket by 2, one of the factors by 2. And you think about dividing 20 by 2, you get 10. Now think of 20, that's 4 times 5 over 2. So I can just divide the 4 by 2, look, that gives me 2 times 5, which is 10. Divide both sides by 7. Well, this side has to be y minus 2 over 7. And this side, well, again, it's the same as times by 1 over 7. And I can't cancel out the 7 with anything, so I have to write that as 3 over 35, 2x add 8. And then rearrange it to give that form by first expand the bracket. So y minus 2 equals 6x over 5 plus 3 times that is 24 over 5. Then I could take the y across, take y from both sides, 6x over 5, take away y, then add 2 to both sides, and using a calculator will give you 34 over 5. And I could times both sides by 5, get 6x minus 5y plus 34 equals 0. Wasn't too nice, too fractiony. First, multiply both sides by 5, so I get 5 lots of y minus 2 equals 3 lots of 2x add 8. So I can expand both sides like that. Then I can take away 5y from both sides and add 10 to both sides, which gives me the same answer, but much easier. Okay, can you try doing the same thing with this one? And then I'll write the answers on the screen. In fact, I'll talk through it. So pause it first to try it yourself. Multiply both sides by 2. That gives me 6, y minus 2. The 2 I would take inside the bracket, look, because it'll cancel out that half. So 2x add 1. Divide both sides by 3. So this side's just y minus 2. Whereas this one I'll just write as 5 over 3, x add a half. Divide both sides by 15. Well, 3. So 3 times 1 over 15 would cancel, give 1 over 5. So I get 1 over 5 y minus 2, and 5 times 1 over 15, the answer is going to be 1 over 3. So 1 over 3 x plus a half. Rearrange by first expanding. So 3y minus 6 equals 5x plus 5 over 2. So take away 3y from both sides, add 6 to both sides. So 6 add 5 over 2 using a calculator will give you 17 over 2. And you could times both sides by 2. So 10x minus 6y, 17 is 0. First times by 2, so first use this one. So 6 lots of that, 5 lots of that. So expand 6y minus 12, 10x plus 5. Take away 6y from both sides and add 12 to both sides. Again, much easier to get rid of the fractions first. So when you look at this, first thing I think of is right, times both sides by 2 to get rid of that 2. But it's not as simple as the reason I put it on there is I don't want you doing this. I don't want you, again, I've seen this mistake a lot. Seeing a half thing, right, times by 2 gets rid of the half. So I times this by 2, I get 6. I times that by 2, I times that by 2. I times that by 2, but then I just leave that on. Or any variation of that. If you times it by 2, you times both sides by 2. Yeah, so I just times the 3 by 2, and I took the 2 inside the bracket, because remember, if I have 3 things times together, so 2 times 5 times x plus half, I can do that in any order I want. So if I do 2 times the bracket, I get 2x plus 1, and then times it by 5. Same with this thing here, if I times that by 2, look. 2 times 3 times y minus 2. I can do that in any order I want. If I do 2 times 3, I get 6, then times 5, y minus 2. Yeah, it's all about this, understanding that multiplication can be done in any order. Really helps with your algebra skills. So I'm going to take another break, and then we'll do the rest later.